to G World Education. In this section, I am taking two non-parallel lines L1 and L2, and L1 having direction cosines small l1, m1, n1, and L2 having line L2 having direction cosines L2, m2, n2. And since these two lines are non-parallel, these are not parallel lines. So to find the angle between these two lines, you just use the formula cosine of theta equal to L1 L2 plus M1 M2 plus N1 N2. And also in place of direction cosines, I can use direction ratio also. Since we know direction cosines can be obtained from direction ratios by using this formula A1 in place of L1, you just use L1 equal to A1 divided by A1 square plus B1 square plus C1 square plus minus, and L2 L1 and your L2 equal to A2 divided by A2 square plus B2 square plus C2 square. And in the similar way, your M1 equal to B1 divided by A1 square plus B1 square plus C1, and M2 equal to B2 divided by this much, N1 equal to C1 divided by this much, N2 equal to C2 divided by this much. So using this, in this equation, you will get cosine of theta equal to A1 A2 plus B1 B2 plus C1 C2 divided by this much quantity. I mean, if the direction ratios of two lines are given to you, I mean if small m A1 B1 C1 and A2 B2 C2 are your direction ratios of L1 L2 and theta is the angle between these two lines, then to find cosine of theta, just use the formula cosine of theta equal to this much. And next case is what will happen if two lines becomes perpendicular. If two lines becomes perpendicular, then what will happen? Theta becomes 90, and we know that cosine of 90 equal to 0. So just put in this formula cosine of 90 equal to L1 L2 plus M1 M2 plus N1 N2, and we know that cosine of 90 equal to 0, then it will gives you L1 L2 plus M1 M2 plus N1 N2 equal to 0. I mean if two lines are perpendicular, then the sum of product of corresponding direction cosines becomes 0, and the same will happen in place of direction ratios. I mean if theta equal to 90, I mean two lines are perpendicular, then the sum of product of corresponding direction ratios becomes 0. So these two are also very useful formula to us. What will happen to their direction cosines or direction ratios when two lines are perpendicular. Then another important thing is, if two lines are perpendicular, I mean if two lines are parallel, and what will happen to their direction ratios. So suppose A1 B1 C1 and A2 B2 C2 be the direction ratios of two parallel lines, then their corresponding ratios becomes equal. I mean A1 by A2 equal to B1 by B2 equal to C1 by C2, and this is the both necessary and sufficient condition. I mean you can say if two lines are parallel, then this relation will occur. Yeah, if we get this relation for certain cases, then you can declare that two lines are parallel. So if A1 B1 C1 and A2 B2 C2 be the direction ratios of two lines, I mean you can say A1 B1 C1 and A2 B2 C2 be the direction ratios of two lines if and only if this will happen. I mean the ratios of their corresponding direction ratios becomes equal. So using all these important concepts, I'll give you two important questions on this. So using all this, so let's see here important questions for you, very important questions in this section. I mean to find the angle by using direction cosines or direction ratios. So here I have to find here I have to prove that the measure of the angle between two main diagonals of a cube is cos inverse 1 by 3. So first of all you have to draw a cube in your three-dimensional space. I mean, here your task is find the angle between two main diagonals of a cube. You know what is cube? Cube means all sides having same unit. So first of all, your task is draw a cube in your three-dimensional space and find the main diagonals of that cube and find the direction ratios of that cube, that two main diagonal, and then you can say the what will be the angle between that two main diagonals. So my first task is I have to draw a cube in three-dimensional space, and the next thing is I have to find the main diagonals of that cube. Since a cube having same units, having all sides same unit, I mean, or suppose I am taking a units, each side having a units. I am just trying to draw a cube in your three-dimensional space. So it's your three-dimensional space O, X, Y, and Z. So name O, A, B, C, D, E, F, G. O, A, B, C, D, F, G. It is your cube having side A units. Okay, so all the sides having A units. So your next task is find the coordinates of each vertices. So coordinate of vertices A should be, since each side having A units and vertices A is on your x-axis, so your x coordinate is here, y coordinate vanishes, z vanishes. So this is A 0 0. Then vertices B having coordinates A 0, vertices C having coordinates 0 A 0, vertices D having coordinates 0 A, vertices E having coordinates 0 0 A, vertices F having coordinate A 0 A, and vertices G, E, F, G having coordinates A, and A, and O having 0 0 0. It's your all vertices. Okay, then your next task is find the two main diagonals of this cube. So to find main diagonals, you have to join a vertices from lower face and opposite vertices from upper face. Suppose I am taking a vertices from this lower face O, A, B, C. Suppose I am taking O as my lower vertices. Then you have to take an vertices from upper face. Upper face means D, E, F, G, and that to be opposite to O. So this is G. So OG is my main diagonal. Then your next step is find another vertices which makes an angle. Find another main diagonal which makes an angle with your OG. So again take a vertices from your lower face and opposite vertices to A which is on your upper face. That to be, if I am taking vertices A from lower face, then I have to take D from upper face, then they will make an angle. I mean OG and AD makes an angle. So this is your AD. So OG and AD are two main diagonals here, OG and AD. Then the next task is very simple. You have to find the direction ratios of OG using the formula x2 minus x1, y2 minus y1, and z2 minus z1. So according to that, your direction ratio should be that should be A. And from direction ratios you can easily find the direction cosines. by using the formula a divided by a square plus b square plus c square square root. So according to that formula, you just recall how to find the direction ratios, how to find direction cosines from direction ratios. All these are present in my previous videos. So according to that formula, I am using that the formula how to find the direction cosines from direction ratios. According to that, direction cosine should be a square plus a square square root, and again the same. If you forgotten, you can go to my previous video for a recall. Okay, so then it becomes 1 by root 3, 1 by root 3 and 1 by root 3. Again find the direction ratios of your another main diagonal. I mean find the direction ratios of main diagonal AD. So that is my minus A and A. And again find the d.cs of AD, and d.cs of AD should be using this formula, minus A by this much, A by this much, A by this much. The same, you just repeat the thing here. Then this will give you minus 1 by root 3, 1 by root 3 and 1 by root 3. Then the thing is very simple. I mean L1, this is your L1, M1, M1, and this is your L2, M2, N2. You know how to find the angle using cosine of theta equal to L1, L2 plus M1, M2 plus N1, N2. So use that formula, you will get the angle between two main diagonals. Then the tax is very simple. So 1 by root 3 minus into minus 1 by root 3, that will give you minus 1 by 3 plus 1 by 3 plus 1 by 3. Then this cancel, then your theta equal to cosine inverse 1 by 3. This is my requirement. I mean I just proved that the angle between two main diagonals of a cube is cosine inverse 1 by 3. Okay, then my next task is to find, the first one is complete here. Then next question is prove that the measure of the angle between the diagonal of a face and the diagonal of a cube drawn from a vertex is cos inverse square root of 2 by 3. I mean just with the same picture I can find the angle between diagonal of the face and the diagonal of the cube should be this much, cosine inverse square root of 2 by 3, and that should be from a single vertex, otherwise they can't make angle. So so you just use the same picture since the question is asking about the cube. So just take the same, this is a cube having a side A units. So just take the same picture and you just take a vertex first. Suppose I am taking vertex O. So by taking vertex O, you have to find diagonal of face and the diagonal of the cube. So first of all, diagonal of the face should be your OB. In your lower face, O, A, B, C, diagonal of face should be OB, and diagonal of the cube is OG, and these two makes an angle. Okay, so in this question, I mean in question number 1, you have to fix a point. Since see the question very carefully, the diagonal of the face and diagonal of a cube drawn from a vertex. So first of all, I just pick a vertex O. I just pick a vertex in this cube, that is my O. You can take another vertex also, but I just take O as my vertex. From O, I just find the diagonal of the face, that is OB, and diagonal of cube is OG. So OB and OG are my requirement. This is the diagonal of the face and this is the diagonal of the cube. Then the task is very simple. Find the DRS. Since coordinates are given here, find DRS, then DCS, then your angle. So simply find DRS of OB. DRS of OB, x2 minus x1, y2 minus y1, z2 minus z1. So I just write here answer of question 2. I just write here. DRS of OB should be your A 0 minus 0, that is A 0. Okay, then DRS of OG is in front of you. I mean also DRS or DCS is also present here. So no need to work for diagonal OG. You just work for the face diagonal OB. So find this is the DRS of face diagonal OB, DRS of OB. Then find the DCS of OB, face diagonal OB. So DCS should be A by A square plus A square plus 0, A by A square plus A square plus 0 and 0 square root. So according to this is 1 by root 2, 1 by root 2 and 0. So this is your DCS of your face diagonal OB, and DCS of your main diagonal is already here. In question number 1, DCS of OG is already calculated, that is 1 by root 3, 1 by root 3, 1 by root 3. So DCS of your OG is your 1 by root 3, 1 by root 3, 1 by root 3. The calculation is here already done. Then the next task is too simple. The next task is the angle between OG and OB and OG. To find this, you just use the formula cosine of theta equal to L1 L2 plus M1 M2 plus N1 N2. So using this formula, since L1 M1 N1 and L2 M2 N2 is in front of you, you just use this formula and find the angle theta. So this is your 1 by root 2 into 1 by root 3 plus 1 by root 2 into 1 by root 3 plus 0 into this much 1 by root 3, that is 0. So this is 1 by root 6 plus 1 by root 6. This implies your cosine of theta equal to 2 by root 6. You can write as root 2 into root 2 divided by root 2 into root 3, and this cancel. Then cosine of theta equal to your square root of 2 by 3, and your theta becomes cosine inverse square root of 2 divided by 3. This is your angle between diagonal of a face and diagonal of the cube from a vertex. Okay. So this is the proof how to find the angle between diagonals of a cube and diagonals and the angle between the diagonal of face diagonal and main diagonal. This is the scenario. By using direction cosines, we can easily find out the angle between diagonals of a cube and the face diagonal and main diagonal. Okay, I hope it's very clear to all of you. Thanks for watching.